When it comes to math, everyone as a student complains, I'm not going to use this in real life. Why do I need to know the quadratic formula to survive in the real world? But then they'll also say, I hate word problems. Well, the word problems are potential real-world scenarios in which you would use these math things that you're learning. You can't say you're not going to use it, and then when it's time to use it, you say you don't like doing it. It's one or the other. Or neither. The best piece of advice that I can give to anyone when it comes to word problems is you need to be a translator first. You need to translate the word sentences into math sentences. Then do the math. Don't skip steps. It's the same thing as order of operations. Don't try to do the math while you're still reading the problem, still trying to figure it out. You're translating something from English into Spanish or whatever language that you want. Spanish is just what I took. Obviously that didn't work out because here I am doing math instead. But math is a language as well, and you need to be able to translate properly, then you do the math. Okay? I'm not going to do any examples of word problems right now. As they come up in the future, I will kind of reiterate all of this and just make sure we're all on the same page. But what I can do is briefly go over the words that you could find in word problems that will lead you to what operation or what is trying to happen so you can translate properly. A lot of them are going to be very obvious. So for like addition, you have plus, added to, increased by, more than, the sum of, sum being answer to a addition problem. Subtraction, you have minus, decreased by, less than, subtract from, subtracted from, diminished by, reduced by. The difference between, difference again is the answer to a subtraction problem. Multiplication, times, multiplied by, the product of, product being the answer to a multiplication problem. But the one that is the least obvious, I think, is the word of. If you see the word of in a word problem, much more likely than not, it's multiplication. Let's say you have 1/2 of 26. This is a very short thing, but there's a bunch of other fluff around, like this calls for a recipe, or we are measuring things and we have a really small person instead, or we only need a small portion of it, or I don't know. One of the things that you will learn to do is cut out the fluffy words, hone in on the relevant information. The story of the story problem, of the word problem, gives you context for what you're trying to do. But once you have that idea, once you understand the context of the problem, that's part of the translation, is making sure the problem that you're translating into, making sure the math sentences match the context of the word problem sentences. Okay, so 1/2, that's easy enough. If you want, you can use a decimal. I like fractions. Of. Multiplication. 26. Well, you can't lose them all. We have translated this into this. Now we can do the math. And then 1/2 of 26 is 13. Yay! Just an example to show you that of means multiplication. Division, divided by, for every. The quotient of, quotient being the answer to a division problem. And here's the other not obvious one. For division, we're looking at the word per. Another not fluffy example. Any example that I can think of that involves the word per for division has to deal with unit rates, which is in a later chapter. I'd rather not jump the gun on that. Okay, we're not. I won't do like a conversion. We can just kind of do a reduction. This is fine. Janice ran 45 miles in 3 hours. How many miles per hour is that? I just kind of came up with these numbers. I don't know if this is appropriate for a person. Either, I don't know, this person's really slow or really fast, or, Goldilocks. But what's fantastic about word problems like this is that it shows you how to set up the problem while you're translating it. Like, you could look at this and say, I don't know what to do, because it's not a math problem. You look at a math problem and be like, I know exactly what to do because it's math, I learned math. But here, you need to be a translator. You need to translate this into a math sentence that makes sense with the context. And this is where a lot of students can get tripped up on. I'm assuming that this is why students get so confused, because you learn so much math, you don't know how to apply it. But the secret is the problem shows you how to set it up. That's the beauty of this. So we have 45 miles, and we can kind of that's going to get really messy really quick. How about just underline that. Feel free to do this. Keep track of your work. 45 miles in 3 hours. Boom. Per. Division. Hour. That's going to be on the bottom, because that's how we set up this division problem here. Oh, and there's 3 of them. How many miles per hour is that? This just means that we kind of want to reduce this, so there's a 1 in the denominator. We'll talk about this. This is a unit rate problem that I said I didn't want to do, but I felt like this was simple enough to just show you why per means division. We want a 1 in the denominator. Here we had multiples of all of these. Here's still a multiple, but then hour per 1 hour. So we're going to reduce this by dividing both the top and the bottom by 3 to reduce the fraction, or you can just divide. Well, 45 divided by 3, it's not in the times tables, I know, so go ahead and whip out your calculator. There's no shame in it, seriously. 15 miles per hour. So for every hour ran, assuming she ran at the same pace the entire time,